Okay, we wait for a while. Waiting your friends. Baru ada 58 orang ni. Yang ni combine G1 dengan G2 kan? Betul tak? Kelas ni maksudnya sepi ke? Tak ada siapa boleh respon? Okay, Assalamualaikum and very good morning to all of you. So, my name is Dr. Hairul Hafizi bin Rohani. So, I will continue the topic for today, which is chapter 7, Overvoltage Phenomenon and High Voltage Transient Analysis. So, for this topic, actually, for the chapter 7, it will contribute 30% from your overall assessment. So from the chapter 7, 8 and 9, it will cover for the OBE2. So the date for OBE2, I think for the week 2 for the exam week. So I hope all of you can take note the date for this subject. Okay, so I hope all of you already uh, already have a full knowledge about the high voltage from based on the previous topic by Puan Safinash and PM Muzame. So today we continue for the chapter 7, which is the overvoltage phenomenon and transient analysis. So according the overvoltage phenomenon, we divided into two parts, which is the part 1 for the lightning. Okay, for the lightning phenomenon, and then in the lightning phenomenon we have some of the theory about the lightning phenomena, and then they have lightning protection, and then we have some exercise example about the traveling wave. Okay, so I hope all of you can remember back about the traveling wave that I've learned from PM Muzami Hisa. So you also will learn about uh, the the voltage transmitted and the reflected voltage according the power line or the power system. Okay, so this is the just for your information for the IEC 671 based on the classification of overvoltage shape. Okay, based on this one, we have two class. Okay, two class, which is low frequency and the low frequency and the transient. Okay, according I think based on the chapter 5 for the impulse generator. So you already know what is the pulse for the transient, and then what is the theoretical about apa the theoretical about the transient, the wave front, the wave tails, okay, and the rest time, and what is the fall times. So this is the very important to contribute for this chapter. And then you can see for the tables for this table, which is the low frequency, the voltage, and or the voltage or voltage shape. For the low frequency is simple, okay, the range frequency like a normal sinusoidal, which is the frequency range is 50 or 60, 50 or 60 megahertz. And then the transient is very fast, so very fast. So the range of frequency for the transient normally in a megahertz. And if you want to find the time of the transient, which is the wavefront, the rest time, which is you can using the standard equation, which is frequency 1 over t, and then for if you want to know the time, you can divide 1 over f. So if you divided the range of frequency, the transient for around the megahertz, you can get the time for the transient is very fast within the microseconds. Okay, so based on the third column, okay, the standard voltage shape. Okay, this is the normal sinusoidal, but for the transient that I said before this, okay, the shape is like like a shooting, okay, like a transient, small transient, okay, or the small spark, okay, for the like a pretty partial discharge, it is a very small spark. But for the lightning phenomenon or surge, the voltage or the amplitude is very high. Okay, and then the standard withstand test. This is the some general info for you. Okay, for the transient, we can do the switching impulse test and the lightning impulse test. Okay, so I want to all of you go to the www.menti.com. Okay, just wait for a while. I will present here. The internet quite slow here, so just wait for a while. I log in first to the mentimeter.com. So before I enter to the mentimeter.com, you can find okay your based on your textbook or the internet. Okay, you can describe what is how the lightning phenomenon can be happen or occur. Okay. Mhm. Okay, all of you can enter to the www.menti.com and then you can use this code 1260. So here we have a 77 students. So I want to all of you uh, answer for this question. Okay, I want to 77 answer. Okay. All right, you can start now. I'll give you 5 minutes. Okay, so you can refer to the internet or the textbook or my lecture notes. Okay, I have shared the lecture note in the Google Classroom, so you can refer the Google Classroom also. Okay, please share your answer now. Okay, describe the lightning phenomenon protection. Okay, good. And the giant spark of electricity in the atmosphere between clouds. Okay, build up the electrostatic charge in the cloud. Okay, good. Okay. I want to ask you, even you refer to the internet or the textbook or the lecture note, so uh, you must you must prepare your words, your own words. Okay, you must rephrase the what you get and then you understand and you write down. So it same goes to the the OBE answer. Okay, if you share directly from the internet your answer, maybe your marks will divide by 2 or I will give directly 0. Okay. Okay. Okay, we have 8 students already shared the answer here. Okay, okay, develop when the upper atmosphere become unstable due to the convergence of warm and solar heated vertical air column on the cooler upper air mass. Okay, lightning is a visible electrical discharge from a cloud. Okay, collision of opposite charge in the sky. Okay, right. Lightning is a visible electrical discharge from a cloud. They happen when there is a imbalance of charge between a region of the clouds and another surface, usually the grounds, the buildings, another region of same clouds or another clouds. Okay, right? Lightning is a natural phenomenon which develop when the upper atmosphere become unstable due to the convergence of warm solar heated. Okay, I think this is internet from the directly copy from the internet. Okay, in the visible electrical discharge from a cloud referred to the to as a lightning. Okay, this occurs when the sufficient charge imbalance between the region is cloud to surface that large enough overcome air resistance. So this is a good point. Okay, natural phenomenon which develop when the upper atmosphere become unstable due to the conversion of warm solar heated vertical air, column, cooler, and mass. Okay, visibility recharge from the cloud happen when there is an imbalance charge. Okay, electric discharge in the air occur between the opposite charge between the thunderstorm cloud happen cause the crash of electron. Okay, electrical discharge caused by imbalance between the storm cloud lightning is a natural occurrence that occurs when the high atmosphere become unstable as a result of convergence warm. Okay, electrical discharge caused by imbalance storm. Okay, alright. Lightning is a weather phenomenon that most occur during thunderstorm. Lightning is a weather phenomenon the most often occurs during thunderstorm. Lightning is a natural phenomenon which develop when the upper atmosphere become unstable due to conversion. Okay, this is same answer. It is a natural phenomenon to the Earth that cause atmosphere unstable when the surrounding become vibrate and expand. Okay, good. Uh, so only 21, 22. Okay. Okay. The answer keep increasing. Okay, good. The viewable electrical discharge from a cloud refer to as lightning. This occur when there is significant charge imbalance between region of the cloud and another surface, usually the ground, a building, another region that same cloud. Okay. Okay, only 23. Yang lain mana ni? Tidur ke? Okay, electricity charge during an electrical storm between electrically charged region of a class. Okay, thanks to the 24 students that have been share your answer here. So your friends can refer the all answer here. But if the question needs you to elaborate, so I hope all of you can elaborate the more on the lightning phenomenon here. Okay, so I want to share to all of you about the simple of illustration of the lightning. So maybe besides you can explain the theory of lightning. So maybe you can draw how the lightning phenomenon happen. So before you know about the lightning, you must know about the cloud. Okay, so the cloud from the cloud, so the lightning phenomenon will be occurs. Okay, so for the first thing, okay, yeah, wait for a while. I want to share back my slide here. Okay, everybody can see my slide.
Cancer.
Okay, I think the internet connection is very slow. I just use the internet Wi-Fi. Okay. Then I need to change the Wi-Fi connection. Okay. So, before you know about lightning or thunder, you must know about the cloud. Okay, I draw the simple cloud here. So normally, how the cloud is how the cloud is developed. So normally, this is the ground. Okay, normally the cloud is become from the ground here. Okay, so this is the ground, and then during the hot summer, okay, during the hot summer, so the hot ground will heat the air, and the warm air will be rise. Okay, okay, and the warm air will be rise. Okay, so when the warm air rise up, so they have some of we can call as uh, the freezing point. Okay, the freezing point during at the top here. Okay, so the warm air will convert to the small of ice. So based on this one, the vapor of air here will become to the will become a small cloud. Okay, so inside here, inside the cloud, during this process, okay, during the long process here, okay, the long process, so the cloud will become larger. Okay, so in the ice in the cloud, okay, in the cloud, so it will bump each other. Okay, the ice will bump each other. So what happened if you remember you do the experiment during your school? Okay, maybe you already done. You gunakan pembaris tu kan? Okay, you rub the pembaris and then you put on your hair. So what happened to the hair? What happened to the hair? You can still remember. You can do now. So it will produce a charge. Okay, so they have a positive and a negative charge here. So in the cloud, the positive charge, okay, they have a two position of the charge, which is the okay when the ice is bump each other, so it will produce the charge, and the charge they will have a positive charge and negative charge. So the positive charge will develop at the top, okay, okay, will accumulate at the top of the cloud, and will the negative charge will be placed at the bottom of the clouds. So if you reflect, if you flashback based on the previous answer due to the imbalance of the charge in the cloud. So it will produce the fast discharge we can call as a lightning. Okay. So however, before the start of the short duration of discharge, like as a lightning here, there will it will cannot directly to produce lightning because they have a air resistant here. Okay, in the simple word, okay, bila sampai satu tahap dia dah tak boleh nak bertahan. Okay, sebelum tu dia boleh bertahan lagi. Okay, tapi disebabkan oleh air resistant. Tapi bila sampai satu, once they reach the certain point level, okay, they will produce the lightning phenomenon, okay, to the ground. So they produce the positive and negative charge, and then they produce the lightning phenomenon. Okay, the order search order under. Okay, so this is the simple of explanation about based on the illustration. So based on the lightning, so we can differentiate, okay, the type of the lightning. Okay, we have a lightning from cloud to cloud, and then the second, which is the cloud to cloud. Okay, so the lightning not produce only not to cloud to ground, but they will produce the lightning the from cloud to cloud, and then they have another one from cloud to the air. Okay, so you can refer my slide here. Okay, so this is the simple uh, the simple description. Okay, lightning is an electrical discharge in the air on the terminal which is cloud. During the storm, charge are accumulated in the cloud and equal charge the opposite polarity are formed in the earth. As this charge increase, the voltage gradient in the air adjacent to the charge center in the cloud is increased. Okay, when the gradient exceeds the insulation strength in the air, low current streamers start downward from the cloud and continues to flow. When the streamer makes contact with the earth, it's like closing a switch between the two charge of opposite polarity, one of the earth and the others in the streamer channel, and the cloud does the large current. So this is the different type of a lightning. So that I explained, which is the cloud to cloud, cloud to ground, and the cloud to air. And then this one, the positive stroke or the blue sky lightning. Okay. So according this one, okay. Um, okay. According this one, we have a two type of the lightning stroke, which is direct and indirect lightning stroke. So how it occurs? Differentiate between the what is the difference between direct and indirect of a lightning stroke? So maybe I can do some raw explanation here. Okay, so this is for the direct stroke. Okay, for the direct stroke, for example, okay, for example, we have the transmission line here. Okay, the transmission line here. Then this is the okay, and then this is the cloud. So for the direct stroke, okay, for the direct stroke, will directly flash to the transmission line. Okay, and then the charge will go to the ground. Okay, so normally for the direct stroke, it will happen to the one which is for the tall objects. So according the direct stroke, we can install the protection, okay, to protect our line. Okay, so from directly to the our line. Okay, so can install protection. However, the direct stroke is normally is very rare occurred in 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 apa kita panggil in nature. Okay, so it's quite rare happen in nature, and then it's only happen to the tons object. So which is the direct stroke. So how to prevent our line from the flashover or the insulator breakdown. So we can install the protection. So the protection, maybe we can install the surge arrestor. Surge arrestor. Okay. So the surge arrestor will capture the lightning and then will absorb to the ground. Okay, right? And secondly, we have a indirect stroke. So how it's happen? Indirect stroke. For example, this is our line and this is the poles. Okay, normally the lightning stroke is not directly to the our line, but it's happened to the other place, but the voltage of the lightning will induce to the line. So the keyword of indirect stroke is the voltage from the lightning induced to the our line, and but the same operation is the operation of the traveling wave is still same to the direct stroke. It will go to the ground. Okay, so based on this one, from based on the indirect stroke, so it will draw back to the traveling time in the line. Okay, so normally our our line is produced the 50 hertz, so it will cause, okay, the oscillation of our line maybe very, it will become a transient. And what happen if our line bila sampai the source to our equipment, so what happen to our equipment if they not receive the 50 hertz of frequency, so what happen to equipment? Tak ada siapa nak jawab ke? Sunyi lah kelas ni. Okay, so what happen kalau equipment kita tak dapat terima 50 hertz, so what happen? Abkari ada Abkari?
Ada.
Tak dengar pun. Sekejap
Ada.
Okay. Apa dia? Abkari. Kalau kita punya equipment tak dapat terima 50 hertz.
Cannot function very well or cannot function properly.
Okay, bukan setakat function properly, tapi kita punya equipment ni dia akan rosak. Okay, sebab tu kalau bila kita tengok kita punya home appliance ke apa semua ni, dia akan tulis the operating frequency which is 50 hertz. So bila ada lightning, okay, bila ada lightning, sebab tu kalau mana-mana kita punya device ke apa, dia ada satu fuse ke apa, so dia akan protect lah from the kita punya equipment daripada rosak. So this is very important, which is we can call as a lightning protection. But if we doesn't have any protection, okay, so you can know what is the effect to the our equipment. That one for the oscillation. But for the traveling wave, okay, normally the traveling uh on the power line we have the traveling wave. But if it once the surge enter to the power line, so it will affect the traveling wave on the power line. Okay, so not only effect on the our equipment before they enter to the our equipment, they will go to our cables and the transformer. So it will cause the insulator will break down, and the transformer winding also will be damaged. Okay, so this is the effect of a lightning to our equipment or the power lines. Okay. According this one, for the lightning, so if doesn't have any protection, so it will affect also to our building, our building system. So mungkin kita punya bangunan tu boleh terbakar, kita punya pokok. Kalau kita biasa kalau kita tengok ada short video, the lightning strike directly to the trees. So what happened to the trees? Okay, so ada pokok yang akan rosakkan, and then ada juga kalau kita tengok video uh, uh, the lightning struck directly, not directly to the people, but direct to the ground. So what happened to the near people on that at the ground? So what happened? So maybe all of you can search at the YouTube. Okay, during some the lightning phenomenon happened during the football training. Okay, so what happened to the football to the player? So they have some shock. Okay, not only one people. So maybe they have a group people on the near place of the of the point lightning strike. And so what happened to the people? So that's why once the lightning phenomenon occurs, okay, bila kita dengar apa petir kilat ke apa semua, so kita kena cepat-cepat masuk rumah lah. Sebabnya dalam rumah tu, sebabnya kat rumah tu kan, okay, kita ada letakkan ataupun kita punya bangunan tu dia ada lightning protection system. But if the building, okay, contoh rumah kita mungkin bersebelahan dengan bangunan tinggi yang ada lightning protection, so mungkin kita punya bangunan yang rendah ni dah tak perlukan lagi untuk lightning protection. Okay, so I want to all of you, okay, go to the mentimeter.com once again. Okay, enter to this. So I just wait for a while. I want to share here. Okay, go to the www.menti.com. Use this code 12605576. What is the lightning protection? So maybe you can share. The what is the lightning protection? Okay, or what is the component of the lightning protection? So in the character is limit to 250. So you can share. You can share here. Okay. I give you 5 minutes. So you can find in the internet the textbook in the channel, and you can find what is the lightning protection. Okay. Okay, nobody can answer this question, lightning protection. Tak ada jawapan pun, mana jawapan ni?
Tak
Dah
keluar pun.
send dah.
Satu student.
Tak keluar pun.
Dah send dah. Saya dah send dah.
Ada dah?
Saya pun dah send.
Ya.
Tak tahu doktor.
Tak tahu dah
Dah
send
send dah?
dah.
Tak naik pun. Tak naik pun.
Wi-Fi Unimed slow ni.
Ya. Saya refresh ya. Nampak saya punya slide ni. Okay. Saya refresh ke? Okay, alright. Okay, thank you. Okay, kita ada 34 dah jawapan. Okay, bagus. Okay, lightning rod. Okay, alright. When lightning strikes, the electric charge pass through lightning conductor to the earth without causing any damage. Okay, for example, lightning arrestor, surge divider, earth, wire, auxiliary device, grounding system. Okay, the function of the lightning protection is to protect structure from fire mechanical destruction and prevent the person building injured or even killed. It has two types, which is external and internal lightning protection system. Yeah, a system to enable high electrical discharge from atmosphere to be conducted safely to Earth by one conductor. Okay, right. Consists lightning rod, conductor, electrode bonding, and lightning arrestor. It is installed to eliminate high voltage energy. Okay. When lightning strike, the electric charge pass through lightning conductor to the earth without causing any damage to the building. For example, lightning arrestor, surge and divider, wire winding. Yes. Function to intercept or conduct lightning strike to the earth. A mechanism system for for preventing individuals within the building from being hurt, killed in the case of fire, mechanical failure, lightning arrestor. Used to prevent the lesser lighting strike damage building. A lightning prevention system purpose to protect structure from fire, mechanical, as well as to keep people within the being hurt or killed. Okay, a lightning protection system offer a safe path for energy from a lightning strike to reach ground, urging the bolt, okay, to avoid damaging the building components. Okay, the function of the lightning strike system, mechanical instruction to prevent the blast kill is okay. Banyak jawapan ni, okay, thank you semua. Okay, so masing-masing boleh tengok jawapan kawan-kawan. Okay, right? Tapi normally the answer is the same objective, to protect from the building or the human from the kill. Okay, so the component, so what the components such as lightning bolt, lightning arrestor. Okay, alright. Provide a better grounding to prevent lightning strike when happen. Grounding also can provide a safe for people around the lightning strike. Okay, safe discharge. Lightning current to the earth via down conductor system, material safe discharge lightning protection. Okay, good. Okay, for your answer. So maybe I can ask somebody here who the FYP project related to the lightning protection or grounding system. Ada tak kawan-kawan yang dekat sini yang FYP dia buat grounding system ke, ada yang buat lightning protection ke? Ada? Siapa tak? Siapa kat sini buat projek FYP? Semalam kelas sebelah adalah 2-3 orang buat. Kat sini ada tak? Siapa tu? Siapa? Tak ada siapa ke yang buat lightning protection? Tak ada siapa buat? Grounding ke? Grounding? Tak ada buat?
Tak ada doktor, semua grup sebelah.
Semua grup sebelah? Grup ni tak ada buat? Ke saja cover kawan-kawan ni? Kak Aisyah buat? Tak ada kan?
Tak, saya
ada
buat
siapa
voltage sensor.
Okay, so tak apa. So kalau ya, balik slide dia. Okay. So apa yang you all share tadi tu, so betul lah apa the main objective of the lightning protection system. So but we must also know the lightning protection system, they have some of a component here. So for example, for the first is the lightning arrestor. Okay, lightning arrestor devices which are used to protect the power system from being damaged from overvoltage by diverting their path to the ground. When the voltage surge reach the arrestor, okay, it spark over the certain prefix spark over voltage, then provide a surge with low impedance path between the earth and the line. Thus, the voltage on the line remain the limit and the power system being safe. So the lightning protection system, the lightning arrestor ni, okay, dia adalah the first component, okay, the first component yang akan capture the lightning to the lightning strike. Okay, so that's why the name is lightning arrested. Okay, and then the second part, the most important, which is the grounding. Okay, so grounding is establish an electrical connection to the earth, establish a common reference point for all voltage related to the given system. Okay, so I think your friends have do experiment or do like FYP based on the grounding system. Okay, yang kalau boleh tengok tu dekat tepi surau tu kan. Okay, banyak kawan-kawan yang buat grounding system kat situ. So normally the objective for the grounding system, they meet the requirement, the standard requirement, which is the value of the soil resistivity, which is 10 ohm. Okay, to make the grounding system is perfect. Okay, so the factor of the affecting ground system for the first, which is the soil resistivity. So the soil resistivity must be low than ohm. And then the application requirement, how the grounding system is to be used. Okay, there are several techniques of the grounding system. Okay, the numbers of the earth interface that are to be provided for one facility, the grounding resistance or surge actually achieve. Okay, so this is the diagram here. Okay, the diagram of the lightning protection in the building. Okay, they have a lightning rod. Okay, lightning rod mounting base, copper cable strap, grounding root clamp, and then the grounding enhancement material, because they need to meet the requirement of resistivity. So kalau tengok kawan-kawan semalam ada yang share, dia punya ada yang letakkan macam apa kan, macam-macam lah. Okay, untuk dapatkan the code of soil resistivity. Okay, so that one for the building. Okay, so what happened? The surge on the transmission line. So this is the differentiate between the I have explained before this, which is the direct and indirect flow. Okay, and then I explained to you the surge will travel along the line at the speed of light. Okay, I think all of you already know the speed of light. Maybe you can Google how much the speed of light. Okay, normally the wave also, but only totally follow the speed of light. Maybe some of the line, maybe macam apa? 3/4 daripada speed of light. Okay, so it's depend on the impedance of our line. Okay, so as they reach the end termination or the junction, partly are reflected and transmitted. So in our line system, okay, not only from the line, maybe the line will join with the cable, and then the cable will join to the transformer, or the line join to the cable, and the cable join back to the line. So the surge that travel along the line, some of the signal will transmitted, and then some signal will be reflected. Okay. Okay, so this is the direction of wave in the J is the junction here. Yeah. Okay, this is the junction. For example, here, this which is the line A and line B. Okay, for line A, line B. But maybe the line A and the line B, the impedance which is Z. Okay, is have a different compare the line A and line B. Okay, maybe also which is the line A and connected to the cable. Okay, so the value of impedance between line and cable also will be different. Okay, for example, this one, the cable. So this is the direction wave. For example, here we have a okay, maybe they have a lightning strike here, so the signal will travel along the line. So this is the lightning pulse. Okay, lightning pulse. Okay, lightning pulse like this one. Okay, they will travel along the line, and then the sum of signal will be transmitted, and then the sum of signal will be reflected. So the parameter that you must know, okay, the parameter that you must know for the direction of the direction wave is you must know the value of the voltage and the value of the current. So they have for the transmitter, okay, they have a voltage ET here, the transmitted voltage, and the current transmitted, which is the IT. And for the reflected, okay, the wave that reflected, they have a voltage reflected and the current reflected. Okay, so you have any question here? Ada soalan tak? Ada tak yang tak faham?
Dia reflect dalam kabel ke macam mana doktor?
Ya, dia akan reflect dalam kabel tu juga. Sebabnya bila the heat dekat kita punya kabel, so dia akan, for example, not only for the direct stroke but for the indirect stroke, okay, voltage tu dia akan ada satu pulse, okay. Satu pulse ni dia akan travel sepanjang kabel tu. Tapi bila dia jumpa satu junction, okay, dia jumpa satu junction, bila impedance dia dah nilai berbeza, so dia akan menyebabkan satu reflection signal, dia akan patah balik. Tapi still ada juga dia punya wave tu yang akan lepas. Yang tu kita panggil sebagai transmitted wave. Yang reflected balik, dia akan masuk balik dalam punya kabel lah. Okay.
Okay.
So, okay. But bila kita ada satu destination, okay, destination. For example, here we have a point A and B. Okay, kalau dekat sini, search ni mula dekat sini, okay, dia akan pergi satu A and then dia ada satu, maksudnya dia akan start dekat junction A ni, okay, daripada point 0, for example, this one, this is a cable. Okay, so signal ni dia memang akan directly transmit dekat this medium ni, medium yang selepas B ni. Okay, tapi dekat in the same cable ni dia akan mantul balik. Okay, dia akan reflect back juga dekat dalam tu. Maksudnya bila dia reflect jumpa first dia akan jumpa B, and then dia reflect back dia akan jumpa A balik, and then dia reflect back jumpa B, and then dia reflect back akan jumpa A sampailah dia punya dia punya signal tu ataupun dia punya voltage ni dia akan attenuate lah, maksudnya dia akan makin berkurang. So this is the illustration of the travelling wave in the line. Okay, so the most important part that you must know, which is the coefficient. Okay, we need to find the value of the voltage reflected and the voltage transmitted based on this coefficient. Okay, for example, this is the value of E, which is the input, right? Okay, the value which is the input, and then this is the voltage reflection based on this coefficient. Okay, you can refer to slide number 23. Okay, so this is the reflected coefficient. Okay, the reflected coefficient, this equation. So I want to all of you please take note this equation for the reflected coefficient and the voltage reflected and the voltage transmitted. Okay. Okay, this is the main thing to all of you must remember before we start the calculation part. Okay, this is for the example here. Okay, this is for the example. This is the surge signal. Okay, from the UT or the value of E And then this one, the value of the first impedance, and this one, the value of the second impedance. Okay, and then the first impedance and the second impedance, they were connected by a junction. So according to this one, okay, the value of alpha is the reflected coefficient, and the beta is the transmitted coefficient. Okay, so based on the transmitted, once they want to, if you want to understand the reflected, okay, once determination have a sum of a reflected signal, okay, once they reflected, you must calculate the value of new alpha, and times with the input from the previous input. From, for example, the value of ET here. So you need to find the new of the value of reflection here, the new reflection 1 in the same medium, means you need to alpha times the ET. Okay. Okay. So how we want to analyze this point? We can use a Bewley lattice diagram. Okay, the Bewley lattice diagram. The diagram to show the position and direction of incident, reflected, and transmitted wave on the system at every instant of time. Okay, so according to the Bewley lattice, we need to also know what is the properties of the Bewley lattice. Okay, the first place here, all waves travel downhill. Okay, kalau you all tengok tadi, okay, slide 24, dia punya bentuk ni dia downhill. Okay, maksudnya dia akan menurun macam tu. Okay, kita tak lukis secara mendatar, tapi dia secara downhill macam kita turun bukit tu. So the first properties is a downhill because time increase. Sebabnya bila the voltage ni nanti dia akan reflected balik. For example, yang ni bermula daripada 0, yang ni daripada T, maksudnya daripada travelling time from point A to the point B, from 0 to the T, and then they will reflect back to the point, it will become 2T. Okay, because the value of velocity is same and the time will be same. For example, yang ni adalah 10 microsecond. So dekat sini, bila kita dah dapat nilai kat sini 10 microsecond, so kita akan dapat dekat sini adalah 2 kali T equal to 20 microsecond. So it is a simple way that you can calculate. Okay, for example, like this one. Okay, let the time taken from the travelling wave from one end offline to other end of the line and k corresponding exponential factors. Okay, so the most important part, okay, the traveling from point A to the point B, it will takes the value, for example, is T. Okay, example T is equal to 10 microsecond. So the reflect back, this one the transmitted, okay, this one the transmitted. And then from the point B to point A, we call as a reflected. And then from the point A to point B, it will still reflect. Okay. So the T is 20 microsecond and the value of the reflected, the time is still same, which is the 2T is equal to 2 microsecond, and then the reflect back 3 equal to 30 microsecond, and then the reflect back, which is the 40, and you can get the 40 microsecond. Okay, so this is the operation of the Bewley lattice diagram. So I want all of you do this exercise, okay, based on the previous punya understanding. Okay, So setakat ni ada, do you have any question tak? Ada soalan tak? Do you have any question about the abilities and the travelling transmitted? Ya, yeah, Hafizul. Hafizul nak tanya ke?
No, doktor.
Tak ada. Ada tak ada? Tak ada. Okay, right, clear? Okay, so I want to all of you, okay, do this example one. An overhead line for which L, which is the inductance, 1.5 millihenry per kilometer, and the value of C, okay, you must draw first. If you, the technique to answer this question, to make you easily, okay, to make it easy, you draw first, okay. For example, the overhead line connected to the cable. You draw the line first, which is it. This is the line, and then connected to the cable. Okay, so they will, here they give a parameter of inductance and capacitance here. Okay, just highlight what the main point here. The value of L, which is the 1.5 what? 1.5 millihenry per km, the value of L, and then the value of C, 0.015 microfarad per kilometer. So how about the cable? The value of cable and the value of C, and then you need to find the value of impedance Z1 and the value of Z. Okay. Berapa nilai Z1? Z is equal L over C. Soalan dia, calculate the voltage and current in the cable. Kita nak dapatkan voltage and current dekat sini. Voltage dengan current dia berapa. Okay, dia punya input voltage dia berapa? Dia bagi berapa? Dia bagi 10
kilo.
10 kV. So nak dapatkan dia punya step tadi tu, you refer back to the equation of reflection coefficient dengan reflection and transmitter coefficient. Okay. So dapatkan nilai Z dulu apa? Z1 apa? Dapat berapa nilai Z? Syaril dapat apa? Nilai Z? Senang kan ni, tekan kalkulator je. Korang dengan kelas ni pegang kalkulator tak? Raja Mani dapat berapa nilai Z? Z1 0.316 0.316 ke 316? 316.228. Okay, right. Tak cantik pula tulisan saya ni. Ya. Okay. So sekarang dapat nilai Z 316. So macam mana kita nak dapatkan nilai current dia? So sekarang voltage dah ada. So the value of voltage dah ada dah. So macam mana nak dapatkan nilai I? Based on simple equation lah, Ohm's law saja. Okay. Okay. E I Z, betul? So nak dapatkan nilai I, apa? Berapa nilai I? E over Z, 10 kV over. Okay, right. 31.62 M. Okay, right. So, sekarang ni kita dah dapat dah nilai dekat sini. So, kita nak tahu nilai yang transmit ni berapa. So, the value of transmit. So, kita nak tahu value ET. Bila transmit, kita guna beta ke alpha? Okay, nilai beta ke nilai alpha?
L beta.
Okay, so beta darab dengan nilai E tadi. Dapat berapa? Find nilai beta dulu. Beta berapa? Apa yang tak tahu ni? Nusaibah tak tahu yang mana? Nusaibah tak tahu yang mana? Kan kat atas tadi saya dah terangkan dah tadi. Dekat sini, kalau reflected nilai alpha, kalau transmitted nilai beta. Tengok balik dekat slide nombor 23 tu. Okay. Sudah berapa nilai beta? Transmit berapa?
Satu 1.8613.
Berapa?
1.8613.
1.8613. Betul? Nilai beta ke nilai
Beta, beta.
beta? 1.8613. Okay. So kali dengan nilai 10 kV. Betul? Betul ke ni? Cuba kira balik. Nilai Z2.
Sekarang tu, terbalik dah Z tu kat mana?
Nilai Z2 berapa? Beta sama dengan 2Z2 over Z1 plus Z2. Berapa? Sikit ni baru simple je ni. Belum kita masuk yang hardcore sikit.
0.1387.
0.1387. 1387. So ganti balik dekat sini. Kali dengan 10 kV. Dapat? Saya nak semua take part lah dekat dalam apa kita punya discussion. Okay, alright. Okay, Afina dapat Muaz. Okay. Okay, nilai Z2 tadi 20. Nilai Z2 sama dengan 23.57. Okay, so akan dapat. So ni salah lah tadi kan. Kita katakan 0.93 dapat nilai E 1387.28. So detail sikit lah. KV ke V? V lah kan? Voltage. Okay, alright. So guna balik berapa nilai IT tadi? IT maksudnya ET bahagi dengan Z2. Berapa?
Saya tutup mic ke, sir? Saya mic tak buka.
Okay, alright, sorry. Okay, so tengok dekat soalan example 2. Okay, dekat sini, the end of two long transmission line A and B are connected by cable C. Maksudnya, you kena lukis dulu. Okay, you all kena draw dulu macam mana condition of kita punya line tu. Okay, kalau dia kata kat sini, the two long transmission line A and B are connected by cable C. Maksudnya, A dengan B, okay, ada A, cable line A dengan line B is connected by a cable C. So first kali you kena tulis dulu, lukis dulu. Cable A, line A, line B, cable C. Okay, you must understand the question here. And then the second part, you must know the impedance. Okay, the impedance. What is the value? L here, the C here, okay, and then what is the value of Z1? Okay, so kalau dekat sini dia kata the lines okay, have capacitance. Maksudnya line A dengan B ni menggunakan same parameter, which is the value of L and C is same. Okay, so the value A Z1 dia diguna pakai untuk kedua-dua tempat A dengan B. And then kita cari pula the Z tu for the cable. Sebabnya dia punya parameter ni is different, right? So kita akan gunakan this one. Okay, and then the rectangular voltage wave magnitude 10 kV and long duration travel long line A toward the cable toward the cable. Draw the lattice diagram during 40 microsecond after the initial surge reach the junction of line A at the cable. So kita kena kira dulu. Okay. Tambah sikit soalan ni kat sini. What will be the voltage at the junction of line A and the cable 20 microsecond after the initial surge reaches this point. Okay. Okay, kita draw satu line dekat sini. Okay, so dekat sini kita ada dua junction. Okay. Kalau kita kan kita ada dua junction A dengan junction B. So yang ni adalah line A and then yang ni adalah cable C and then this is the line B. So siapa dapat nilai Z1? Nilai Z1 apa? Berapa nilai Z1? Berapa nilai Z2? Okay, ni kita dah mula start draw probabilities So masing-masing boleh follow this step. Okay. So kalau kita ingat balik, dia punya parameter the properties of blue, that is dia mesti down kat sini and then dia akan transmit, okay, dia akan ada satu transmit and then dia akan ada satu reflect juga dekat sini. Okay. So dekat sini dia kata tadi dia akan bagi the value kabel ni adalah berapa panjang dia? Dia bagi tahu panjang dia CD adalah 1.5 km. 1.5 km. Okay, berapa nilai Z? Tak ada siapa dapat ke? Okay, the start dekat sini adalah 10 kV. Maksudnya nilai E dia yang pertama. So kita nak dapatkan nilai E yang ke, bukan E2 lah. Maksudnya ET. Kita dapatkan nilai ET dia berapa? Okay, nilai Z1 is equal to 400 ohm. So equally Z1 line for the line A and B is same. So this one the 400 ohm. The value of Z2, betul. Okay, Z2 75. Okay, betul. 75 ohm. So bila dah dapat nilai Z1 dengan nilai Z2, so kita boleh cari dah berapa nilai alpha dia. Okay. So dekat point ni berapa nilai alpha dia, dekat sini berapa nilai beta dia. So berapa nilai beta tu? Berapa nilai beta? Okay, ingat balik equation beta berapa? 2Z2. Okay. 2Z2 over Z1 plus Z2. Betul. Yang tu nilai beta 0.316. Transmit kan? 0.316. So berapa nilai transmit dia berapa? Okay, so kita akan dapat nilai ET 3.16 kV. Okay, dapat. So, berapa nilai alpha? Berapa nilai alpha? Ada siapa yang boleh kira? Negatif 0.8. So kita boleh dapat nilai kan nilai E reflection dia berapa? Okay, kali dengan 10 kV dapatlah negatif 6.842 kV. Okay. So sekarang ni the value yang kita tak dapat lagi adalah nilai T dekat sini. Okay, the value of T here. So macam mana kita nak dapatkan nilai T? Okay, the main thing that you must know which is the value of velocity. V is equal 1 over square root LC. Okay. So kita nak tahu dia punya T dia adalah S equal to VT. S means here the distance. Okay, atau the value of length dia. Okay, nak dapatkan T equal S over V. So you find the nilai V and then you will got the value. The value S is equal to 1.5 kilometer and then you can get the value of T. Okay, saya akan cepat sikit.
So V tu yang 1 over square root LC tu, dia untuk kabel punya LC lah.
Ya, betul. Dia untuk kabel saja.
Okay.
Okay. Okay. So T dekat sini you akan dapat 10 microsecond. Okay. 10 microsecond. And then dekat sini 2 T ni of course lah 2 microsecond and then dia akan reflect back. Sebabnya bila soalan dia tanya berapa nilai selepas daripada 20 microsecond, so kita akan cari selepas daripada 20 microsecond itu voltage yang kat sini lah. So dekat sini yang ni adalah transmit, tapi bila kat sini macam I told you before, this value is the value of reflection. Bila value of reflection, you must know the value of alpha here. Okay. So the alpha based on this impedance yang dekat sini dan juga impedance dekat sini. Okay. So nanti kita nak dapatkan dia punya nilai dia, kita nak dapatkan E total dia. E total selepas daripada 20 microsecond, you akan dapat E total dia sama dengan 3.16 kV plus dengan value E reflection 1 and then plus dengan E reflection 2. So alpha ni you times dengan nilai ET. So nilai ni reflection based on nilai E R1. Okay, dia punya input ni dekat sini. Kalau yang ni adalah input dekat sini, yang ni adalah input dekat sini. Okay, so ER1 plus dengan ER2. So you akan dapat the final answer is 6.7971 kV. Okay. Okay, so I want all of you continue your calculation part. So maybe I need to dismiss for this class first because I have a short meeting. So I give you this final answer that you can get after this. So we will meet again our class on next Thursday, right? Okay, at the same time. Okay. Okay. So if any question, you can direct contact me to the WhatsApp atau direct me to my personal WhatsApp or to the personal or the group WhatsApp, group class WhatsApp group. So I think that's all for today. And thank you very much. So all of you can continue this exercise. I want all of you repeat and repeat back for the example 1 and example 2 until you can understand the operation of the video lattice diagram is here. Okay. So for now, any question?
Saya nak tanya,
Okay.
yang garisan-garisan tu kan dia punya jarak tu suka hati kita je. Kita nak
Yeah, dia tak ada ni lah specific angle lah. Tapi kalau seeloknya you letakkan the same angle lah sebabnya dia punya travelling time ni adalah sama. So angle, kalau apa tak sama pun tak apa lah tapi ada bentuk lah. Tapi make sure jangan nampak berbeza sangat lah dia punya ni. Okay. Alright. So sampai di sini saja. So ada question lagi? Ada tak? Okay, biasanya yang saya nak nak saya apa?
tak ada.
Tak ada Okay, so biasanya yang student akan buat mistake kat sini adalah nilai dekat sini ni. Nilai alpha ni. Okay. Dia akan menggunakan nilai beta. Tapi sebetulnya yang ni dia bukan transmit. Dia adalah reflect daripada kabel to line B ni. So pastikan you gunakan nilai alpha ni reflected. So kalau tak ada apa sampai di sini saja dulu. So thank you very much. So kalau ada apa soalan just contact direct dekat saya ataupun dalam WhatsApp group lah. Saya akan share this video recording to the Google Classroom. So thank you very much and Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Okay, alright.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, welcome.
Thank you, sir.
Okay, right.